So yesterday we have completed our topic is that AC circuits हा जो टॉपिक आहे तो आपण कालच्या लेक्चरमध्ये कंप्लीट केलेला होता. Today we have discussed about the next topic is that dual nature of radiation and matter. आता जो आपला नेक्स्ट टॉपिक आहे तो आपण इथे बघणार आहोत ड्युअल नेचर. कुणाचं ड्युअल नेचर ऑफ रेडिएशन अँड मॅटर. सो हिअर टॉपिक नंबर 14. Here dual nature of radiation and matter. Dual nature of radiation dual nature of radiation and matter. So dual nature of radiation and matter. सो याच्यामध्ये काय आहेत ते पॉइंट्स आपण बघणार आहोत. फर्स्ट ऑफ ऑल आपण इथं बघू फोटोइलेक्ट्रिक इफेक्ट. द फोटोइलेक्ट्रिक इफेक्ट. द फोटोइलेक्ट्रिक effect. Henrich Hurst discovered the photoelectric emission in 1887 while he was working on the production of electromagnetic waves by spark discharge. Scientist name काय बघा. Henrich Hurst. Henrich Hurst. So Henrich Hurst discovered photoelectric emission in 1887. Photoelectric emission. सायंटिस्टचं नाव काय आहे? हेनरिच हॉर्स्ट. हेनरिच हॉर्स्ट discovered photoelectric emission in 1887. त्यांनी किती डिस्कवर केलं बघा 1887 मध्ये. While he was working on the production of electromagnetic waves by spark discharge. तर नेक्स्ट सायंटिस्ट आहेत हेनरिच हर्ट्ज. ओके, जस्ट 2 minutes. Okay, so photoelectric effect. So first scientist is that Henrich Hurst discovered the photoelectric emission in 1887. So while he was working on the production of electronic waves by spark discharge. The first of all here we draw the diagram, then understand the concept. So first of all here we draw the diagram, then conceptual understanding easy. Where is my chalk? So Henrich Hurst discovered photoelectric emission in 1887 while he was working on the production of electromagnetic waves by spark discharge. He noticed that when ultraviolet light is incident on a metal electrode, a high voltage spark passes across the electrodes. So actually electrons were emitted from the metal surface. So the surface which emits electrons when illuminated with appropriate radiation is known as photosensitive surface. Actually, whenever he performed experiments, he noticed that when ultraviolet light is incident on a metal electrode, a high voltage spark passes across the electrodes. So actually, electrons were emitted from the metal surface. The surface which emits electrons when illuminated with appropriate radiation is known as photosensitive surface. The phenomenon of emission of electrons from a metal surface when radiation of appropriate frequency is incident on it, as shown in figure, is known as photoelectric effect. So therefore, the phenomenon of emission of electrons phenomenon of emission the phenomenon of emission of electrons the phenomenon of emission of electrons from a metal surface so phenomenon of emission of electrons from a metal surface and radiation of appropriate frequency radiation of appropriate frequency is incident on it. Radiation of appropriate frequency is incident on it. As known as photoelectric effect. Is known as photoelectric effect. Let's open the photoelectric effect. So the phenomenon of emission of electrons from metal surface when radiation of appropriate frequencies incident on it is known as photoelectric emission. This is a metal surface. Whenever the appropriate radiations are falling on that surface, then some electrons are ejected from the metal surface. This is known as photoelectric emission. There are just emission of the electrons. So it is nothing but a photoelectric emission. Okay. For metals like zinc, cadmium, magnesium. Okay, which are the metals like zinc, cadmium, magnesium, etc. Ultraviolet radiation is necessary while for alkali metals, even visible radiation is sufficient. So electrical energy can be obtained from light, that is electromagnetic radiation, in two ways: photoemissive effect as described above, and photovoltaic effect used in solar cell. So an electrical potential difference is generated in a semiconductor using solar energy. Okay. Next point is that experimental setup of photoelectric effect. Experimental setup. Experimental setup of photoelectric effect. Photoelectric. First of all, here figure is important. So here we draw the figure. सगळ्यांनी फिगर ड्रॉ करून मला व्हॉट्सअप करायचे आहे. These are the electrons. This is a quartz window. ही आहे ती सांगणार आहे मी क्वार्ट्ज विंडो आहे. त्यानंतर वरचा आहे तो सोर्स आहे एस. सोर्स एस. This is photosensitive emitter plate. Collector plate. Commutator. Microampere voltmeter and variable potential source. This is the schematic of experimental setup for photoelectric effect. So this is the experimental setup. So typical laboratory experimental setup for the photoelectric effect consists of an evacuated glass tube with a quartz window containing a photosensitive metal plate, the emitter E, and another metal plate, the collector C. So this is a typical laboratory experimental setup for the photoelectric effect, which consists of an evacuated glass tube. ज्याच्यामध्ये काय कन्सिस्ट आहे, एक इव्हॅक्युएटेड ग्लास ट्यूब आहे विथ अ क्वार्ट्ज विंडो. इव्हॅक्युएटेड ग्लास ट्यूब विथ क्वार्ट्ज विंडो कंटेनिंग अ फोटो सेन्सिटिव्ह मेटल प्लेट. की ज्याच्यामध्ये काय कंटेनिंग आहे बघा, फोटो सेन्सिटिव्ह मेटल प्लेट आहे. आणि ती फोटो सेन्सिटिव्ह मेटल प्लेट कोणती आहे, द इमिटर ई अँड अनदर मेटल प्लेट द कलेक्टर सी. सो इमिटर अँड कलेक्टर आर कनेक्टेड टू अ व्होल्टेज सोर्स whose voltage can be changed and to an emitter to measure the current in the circuit. A potential difference of V as measured by the voltmeter is maintained between the emitter and collector C at the anode. So normally C being at positive potential with respect to the emitter. So this potential difference can be varied. So this potential difference can be varied and C can even be at a negative potential with respect to E. So when the anode potential V is positive, it accelerates the electrons, hence called accelerating potential, while when the anode potential V is negative, it retards the flow of electrons, therefore known as retarding potential. The source S of monochromatic light corresponding to only one specific frequency of sufficiently high frequency wavelength, that is 10 raised to minus 7 which is used. So light is made to fall on the surface of the metal plate E, and which electrons are ejected from the metal through its surface. So these electrons called photoelectrons, which are collected at collector C. So they are given this name to indicate that they are emitted due to incident light. So we now know that free electrons are available in a metal plate. So they are emitted with sufficiently energy. So if supplied to them to overcome the barrier that keeps them inside the metal. So in the late 19th century, these facts were not known, and scientists working on photoelectric effect, which performs various experiments and noted out their observations. We will try to analyze these observations. Next point. So here, this is the experimental setup. The experimental setup of photoelectric effect, which is a typical laboratory experimental setup, consists of evacuated glass tube. आता हे काय आहे, typically laboratory experimental setup आहे. की ज्याच्यामध्ये काय काय कन्सिस्ट आहे, एक evacuated glass tube आहे, in which the two plates are consist. That is, first plate is that photosensitive emitter plate which ejects the electrons, and another plate that is a collector plate which absorbs the electron. We know that electrons are negative charge, so C must be positive potential, so they need to accept the electrons. So the two ends of that plate are connected to the commutator, that is potential variable changes. So here microampere, that is ammeter to connect to measure current flowing through that circuit. Voltmeter is used to measure the voltage between the two plates. So this is a resistor, this is a variable potential source. Here we commutator is used to reverse the polarity. C is a positive potential. We reverse the polarity by using this commutator function. Okay. So it consists of a evacuator glass tube. Here E be the photosensitive emitter plate and C be its collector plate. Whenever the high frequency of radiations are or suitable frequency of radiations are from the source are incident on that emitter plate. So due to this, a number of electrons are ejected from that plate. म्हणजे जेव्हा आपण सुटेबल फ्रिक्वेन्सी ऑफ रेडिएशन्स त्या इमिटर प्लेट वरती काय करतो इन्सिडेंट करतो a number of electrons are ejected, but this frequency or radiations are in large proportion. Okay, so the number of electrons are just ejected, which are collected by the ejected plates. So in this way it's experimental setup. So this is a photosensitive emitter plate. This is a quartz window in which source are transported incident the waves on the emitter plate. This is electrons, this is collector plate, this is a commutator, microammeter, voltmeter, and this is a variable potential source. So this is all the typical laboratory experimental setup for the photoelectric effect. Okay. So next article we study its working. So next point, that is observations from experiments on photoelectric effect. Observations from experiments. Observations from experiments. Observations from experiments on photoelectric effect. The next point आपला काय आहे observations from experiments on photoelectric. So here observations from experiments on photoelectric. What are the observations? First point, when ultraviolet radiations was incident on an emitter plate. This is ultraviolet radiations are emitted on a emitter plate. Current I was recorded even if the intensity of radiation was very low. So photoelectric current I was observed only if the frequency of incident radiation was more than some threshold frequency mu naught. So mu naught was some same for given metal and was different for different metals used as the emitter. So for given frequency, nu is greater than mu. Given frequency nu was greater than mu naught of the incident radiation. So no matter how feeble was the light, meaning however small the intensity of radiation be, electrons were always emitted. So your first observation is that when ultraviolet radiations was incident on the emitter plate, so current was recorded even if the intensity of radiation was very low. So photocurrent I was observed only if the frequency of incident radiation was more than some threshold frequency nu naught. So nu naught was same for given metal and was different for different metals used as the emitter. So for given frequency, nu is greater than nu naught of the incident radiation. So no matter how feeble was light, meaning however was small intensity of radiation be, electrons always emitted. So this is the first observation. Second observation is that there was no time lag between incidence of light and emission of electrons. There was no time lag there was no time lag between the incidence of light, between the incidence of light, between the incidence of light, between the incidence of light and emission of electrons, and emission of electrons. So the photocurrent started instantaneously, that is within 10 to minus 9 seconds, on shining the radiation even if the intensity of radiation was low. So as soon as the incident radiation was stopped, the flow of current also stopped. Third, keeping the frequency nu of incident radiation accelerating potential will be fixed. If the intensity was increased, photocurrent increased linearly with intensity. So as shown in figure, that is intensity of incident light. Intensity of incident light. So here photocurrent. Here photocurrent I. So photocurrent as a function of incident intensity for fixed incident frequency and accelerating potential. So here we discussed about only 3 points. या ठिकाणी आपण डिस्कशन फक्त कशाच करतोय, एक 3 पॉइंटचं डिस्कशन करतोय. ऑब्झर्वेशन्स फ्रॉम एक्सपेरिमेंट्स ऑन फोटोइलेक्ट्रिक इफेक्ट. So what are the observations? So for given frequency nu is greater than nu naught. आपली असणारी जी फ्रिक्वेन्सी आहे, समजा न्यू जर फ्रिक्वेन्सी असेल आणि ही फंडामेंटल फ्रिक्वेन्सी जर आपली थ्रेशोल्ड फ्रिक्वेन्सी पेक्षा जर ग्रेटर असेल, देन अँड देन ओनली द electrons are ejected from the metal surface, otherwise no electrons are ejected. When radiations or suitable frequency of radiations are incident on that emitter plate, then what happens? It is just a flow. There is a photocurrent I was developed within them, but a certain radiations which is greater the threshold frequency, then and only then the electrons are ejected from that surface. Otherwise no. If just low value of incident radiations are incident on the emitter plate, no current will be produced and no radiations are takes place.